Hi guys, I'm David Paul Liju from 1BCDS and we are going to do a short video on the topic relations and database. So the topics which are going to be covered under this video are what are relations, what are database, what are different types of databases, and what is relational database, join function, what is the difference between relational database and non-relational database. Okay, so now let's move on to our topic, that is database. So what is database? So database is a collection of information or data which is stored and organized in a way that it is easy to access, easy to manage, and easy for making updation.
Relations. What are relations? Relations can be described as a collection of ordered pairs. It is used to relate one object from one set to another set, and that set must be non-empty set, which means that set must contain some elements. It can be A, B, C or any set. The relation can contain two or more than two sets. For example, let's suppose there are two sets, set A and set B. Set A contain an object C and set B contain an object called D. The object will be related to each other if there is a relation of ordered pair C, D. There are different types of relations. First is one-to-one relation. Second is one-to-many and many-to-one relation. And the third is many-to-many relation.
We are discussing about the different types of database. There are mainly 5 types of database: hierarchical database, network database, object-oriented database, relational database, and NoSQL database. So, hierarchical database. It is a type of database that stores data in the form of parent-children relationship nodes. Here it organizes data in a tree-like structure. So, data gets stored in the form of records that are connected via links. Each child record in the tree and contains only one parent. While on the other hand, each parent record can have multiple child records. And the next data is network database. It is the database that typically follows the network data model. Here the representation of data is in the form of nodes connected via links between them. Unlike the hierarchical database, it allows each record to have multiple children and parent nodes to form a generalized graph structure. Next is object-oriented database. It is a database that uses the object-based data model approach for storing data in the database system. The data is represented and stored as objects which are similar to the objects used in the object-oriented programming language. Relational database. This database is based on the relational data model, which stores data in the form of rows, which is tuple, and columns, which is attributes, and together forms a table which is said to be a relation. A relational database uses SQL for storing, manipulating, as well as maintaining the data. E.F. Codd invented the database in 1970. Each table in the database carries a key that makes the data unique from others. Relational databases included MySQL, Microsoft SQL, Server, Oracle, etc. There are 4 commonly known properties which is known as ACID. A means atomicity, C means consistency, I means isolation, and D means durability. Next is NoSQL database. NoSQL, or not only SQL, is a type of database that is used for storing a wide range of data sets. It is not a relational database as it stores data not only in tabular form but in several different ways. It came into existence when the demand for building modern applications increased. Thus, NoSQL presented a wide variety of database technologies in response to a demands. We can further divide this database into 4 types: key value storage, graph database, document oriented database, and wide column database. These are the main 5 types of database. There are also different kinds of database like centralized database, distributed database, cloud database, personal database, operational database, enterprise database, and etc.
I am Michelle Miranda and I will be talking about relational databases.
A relational database is a collection of data which has a predefined relationship between them. These items are organized as a set of tables with columns and rows. It is based on the relational model of data as proposed by E.F. Codd in 1970. A relational model organizes data into one or more tables or relations of columns and rows. Each row is also referred to as a record or tuple, and the total number of rows in a table is known as the cardinality. Each column is also known as the attribute or field, and the total number of columns is known as a column is also referred to as an attribute or field, and the total number of columns in a table is known as degree. One important feature of a relational database is that each row is identified by a unique value known as the key. This common field or key links two tables together. A few examples of well-known relational databases include Oracle, SQL Server, MySQL, and IBM DB2.
Now try to better understand relational databases with the help of some examples. The following table displays student information. Each of the rows, also referred to as record or tuple, contains a single unit of information about a student. The cardinality or total number of rows present in the table in this case would be equal to 4. The columns, also referred to as field or attribute, contain information of a single data type. The degree or total number of fields present in this case would be equal to 3. An important feature of a relational database is the fact that each record can be identified with the help of a unique value, also known as primary key. In this case, the roll number field would be our primary key. While designing a database, we look for attributes or fields in a table which help us in uniquely identifying a row. In this case, roll number as well as Aadhaar serve as candidates for becoming a primary key. Each table, however, must contain one and only one primary key. We can also use a combination of two or more attributes to serve as a key, and this is known as a composite key. In the following example, the roll number attribute present in the result table is a foreign key which links us to the primary key present in the student table. Relational database consists of multiple tables that are linked to each other with the help of foreign key. A foreign key is an attribute in a table that refers us to the primary key of another table. Let us now go on to understand the three different relations that are used in these databases. Firstly, the one-to-one relationship. In this, a single record of a table is only referencing a single record of another, and vice versa. In the following example, each member ID references only a single unique driver license ID. On the other hand, each driver ID references only a single member ID. Thus, both the members to driver's license and driver's license to members relationship is that of one-to-one. Secondly, we have the one-to-many or many-to-one relation. In such a relation, a single record in one entity may reference multiple records in the other, though within the other entity the records may only reference a single record of the initial one. In the following example, we can see that a single member might have made multiple transactions on different days. Thus, each member can have multiple rental IDs. On the other hand, each rental ID relates to only one member. For instance, rental ID 2, ID 3 and ID 4 all were transactions made by member ID 2, thus relating to only one member. Thirdly, we have the many-to-many relationship. In this, records in both tables may reference multiple records in the other. In our example, a movie might be rented out by different people on different occasions. Thus, each movie ID can reference multiple rental IDs. Similarly, in each transaction, a customer might have rented out more than one movies. Thus, a single rental ID could reference more than one movie IDs. So, movies to rentals and rental to movies show a many-to-many relationship.
Hello, I'm Kavya and today I'm going to talk about types of joins. Join operation combines two relations with respect to a given condition. It pairs two different relations if and only if a given condition is satisfied. There are two types of joins in relational databases: inner joins and outer joins. Inner join is used to return the records from both the tables which satisfy the given condition. It is the most widely used join operation and can be considered as the default join technique. An outer join doesn't require both the tables to have matching records. In this type of join, each record is retained even if there is no match found.
Inner join is further divided into three subtypes: theta join, natural join, and equijoin. Theta join allows us to merge two tables based on a condition represented by theta. Theta join works for all comparison operators like equal to, less than, and greater than. The general case of join operation is called a theta join. Consider two tables, student and subjects. Table student consists of student ID, name, and standard. Table subject consists of class and subject. The common attributes are the standard column in table student and the class column in table subjects. When theta join is applied, there are four rows in the resulting table. Here we can see that both tables have been merged on the basis of a condition. That is, standard column of table student is equal to class column of table subject. Natural join does not utilize any of the comparison operators. Here, there should be at least one common attribute between two relations. It acts on those matching attributes where the values of attributes in both the relations are same. Consider two tables A and B. Table A consists of columns number and the square of the number. Table B consists of columns number and the cube of the number. The common attribute is the column number. When natural join is applied, the resulting table has three columns: number, the square of the number, and the cube of the number. Note that the column number has only been written once. Equijoin is when theta join uses only the equivalence condition. It is the most difficult operation to implement efficiently in an RDBMS. Consider the two tables student and subjects. Here, when equijoin is applied, we get four records in the resulting table. Hence, equijoin can be considered as a special case of theta join.
Hello, my name is Kanchan Karmakar and I am from 1 BSc DS. Now I am going to start about a topic known as database. Database is a software used to identify, manage and create database that provides administration and give access to the data. So our next topic is that relational database. So relational database is more advanced version of the database system that allows us to access the data in a more efficient way. It is used to store or manage only the data in the forms of tables. So the next thing is the difference between the database and relational database. So relational database store data in a table format, whereas database store data in the file format. And in relational database, multiple table elements are acceptable together, whereas in database, individual access of data elements is available. In relational database, data is in the form of table are linked together, but in database system, no connection between the data. So next is next in the relational database, the support is distributed in the database, but in database system there is no support distributed as like in the relational database. And in a relational database, the data is stored in a large amount, whereas in database system the data is stored in a small quantity.
Hope you guys understood what is database, what is relations, what is relational database, and all the concepts which are covered in the video. And if you have any doubts, you can comment it below. And our group members are Taniya, Shruti, Michelle, Kavya, Kanchan, and myself, David. Thank you and have a nice day.